So we've calculated the variance, but remember the purpose of the variance is to kind of understand what is the normal amount of deviation for this entire group, okay? So does it really normal for the entire group to vary 5.78 years? Is that really what's going on here? No, the standard deviation, remember the way we got to this score, this variance right now, is we took all of the deviations, we squared them, we added them up, and then we divided by the n. For the population is for the n, for the sample is n minus 1. But this means that the stuff that we have right here is squared. To understand what is a normal amount of deviation in our sample, we are going to take the square root of that. That's going to give us what we call the standard deviation. We don't call it the average deviation because it's not an average. We don't call it the mean deviation because it's not a mean. It is a standard deviation because we had to square all the deviations first. Then we divided it by n. Now we're going to take the square root to get rid of those squares. So this is going to be the standard deviation. It is going to be the variance, the square root of the variance. I should do this correctly. Square root of the variance. 2.403. 2.403. This is going to be, that's a lowercase sigma. That stands for standard deviation for a population. Standard deviation for a population. What that means is that in the entire population of all the members of Menudo, a standard amount for people to deviate from the mean is about 2.4 years. It's pretty normal for people to deviate 2.4 years above the mean, 2.4 years below the mean. That's a standard. That's one standard deviation. So remember, the entire question was, how strange is Ricky Martin? How strange is Ricky Martin? So when we look at Ricky Martin deviates 1.44, right? Okay. His tenure was 5 years. That's 1.44 deviations above the mean. The standard amount for people to deviate is 2.4 deviations above the mean. So he's within one standard deviation above the mean. He's not that strange. It depends on how you define what strange means, but he's within a standard deviation, right? It's pretty standard for people to be within 2.4 years above or below the mean. So that means that if we look here at Montañez, that he is also within a standard deviation from the mean. He just happens to be below the mean, right? He is 1.56 years below the mean. The standard deviation is 2.4 years above or below the mean. All right, let's try this then for the other data that we have. What is the standard deviation for this sample? The way we find it, so this is going to be the standard deviation, which is just the lowercase s, because this is a sample. All we do is take the square root of the variance. The only difference between a population and a sample is when we calculate the variance. The standard deviation, you just take the square root. So this is the square root of the variance. There it is right there, 2.87. So if we look at this and say, all right, I want to know, is participant number one strange? Is participant number one strange? Well, not really. They're within one standard deviation. It just happens to be below the mean. So the deviation of how much they like donuts is a negative 2.43, right? So they're about 2.43 liking units below the mean. Well, the standard deviation is 2.88 units above or below the mean. And so they're not particularly strange. Participant 1 is not particularly strange. If you look at participant 4, however, 3.57, that's a lot more than one standard deviation above the mean. So they're more strange. Participant 4 is certainly over one standard deviation above the mean in how much they like donuts. Just a couple of last questions before we finish this up. But boy, the standard deviation is hugely important. Please understand what a standard deviation is. It is just saying basically it's like the average deviation away from the mean, but it's not an average. That's why it's called a standard deviation. If somebody is within a standard deviation, then they don't deviate very much. They're within a standard deviation above or below the mean, right? They don't deviate very much. If they're more than a standard deviation, or especially if they're more than 2 standard deviations, then we got a different story. And we'll talk more about those in a little while. But you need to understand what a standard deviation is. Let's do a few review questions and then we can be done. So, few questions. The mean of variances for a sample is, it doesn't make sense to do a mean of variances. There's only one variance for the whole sample. Any distribution of scores, whether it's in the population or in the sample, has one variance. So let's go through these different amounts of variability. All right, so you'll have one range for the whole distribution, but you will have as many deviations as you have participants. Each participant has their own deviation. So the mean of deviations is 0, right? But you only have, but that's the only thing that you have an individual score for each participant, right? Each participant has their own deviation. So you can get a mean of the variance, mean of the deviations, and that's going to be 0, right? But you only have one sum of squares, you only have one variance, and you only have one standard deviation for your distribution. Okay? You have many deviations, you only have one standard deviation. The variance is the average deviation from the mean. Well, that's false. It's not the average deviation from the mean, because the average would literally be 0, right? Because it calculate it that way. And even then, even if you say, well, no, what we did was we squared it, and then we got the average. Well, that's the average squared, if you think about it that way, right? It's the sum of squares. It's the squared deviation. It's kind of like the mean squared deviation from the mean. So this variance it's getting close to that, but it's not the same thing. It's not an average. It's not a mean. It's trying to take the place of it. Specifically, the standard deviation is trying to take the place of a mean deviation from the means. The mean of standard deviations for a sample is, it doesn't make sense to get a mean of standard deviations from the sample because there's only one standard deviation from a sample. There's only one standard deviation for a sample. There's only one standard deviation. There's only one variance. There's only one sum of squares. There are lots of deviations. There's as many deviations as there are participants. There's only one standard deviation. All right, thanks everybody.